Time. Okay. Hey, did I talk about these two guys yesterday? Right? Pythagoras and Einstein. It was you, wasn't it? All right. You didn't know the answer to Pythagoras. Sorry, calling you out again. But anyway, okay. So that's a chapter 2 question. That literally is a chapter 2 question. This isn't chapter 2 anymore. But maybe write this down real quick and write this idea. When you inverse sine both sides, that frees x to equal whatever this answer is. And if I were allowed to use my calculator, I would. I'd press enter. I'd get 30, and then I'm supposed to find the other one, the quadrant 2 one, which is 150. So kind of put that in your mind. No calculator, but this is what you type on your calculator. So I really want you to embrace the next idea. Then today should be super easy. It's actually just a little algorithm, a little thing that's created by this conundrum. And if you're writing the notes, definitely write these directions and really highlight, I need all answers from 0 to 360. Big deal, Mr. S. 30 and 150 are the answers. You're right. Wait till you see the next thing, though. Creates a conundrum. We're not drawing triangles anymore, but I was just kind of like showing you, hey, back in chapter 2, this is what we did. We did, okay, 1 is the y, 2 is the hypotenuse. This has to be root 3 by the Pythagorean theorem. The reference angle is 30. And then we did 30, and then 180 minus 30. We're all there. I think, as much as I want to complain yesterday, I think we finally got 2 and 3 down. I actually feel like you're better with radians now than degrees, which is good. Okay, so now here's the problem. Now here's the next one. I want to zoom in on this because these are lazy notes today. But then I'm just going to create some examples after just from my brain, which is what I used to do on the boards all the time. And it was great lessons, and the students were more than successful with my board examples. So again, you'd inverse sine, but wait a minute. What's different with this question? The what number? 3, 2, 1, go. 2. What you have to understand is, okay, fine, I can inverse sine both sides, but here's what you freed. You freed 2x now to be able to be solved for, not 1x. By the way, how do you solve for 2x equals always? What do you do next? 3, 2, 1, go. Divide by 2. So that is why you really, as a note taker, want to write this down. This 2 changes, well, really 2 things, but here's one of them. To solve for x, I'm going to need to divide by 2. So it's very simple. The first thing is 2x equals, what does the calculator tell you only when you inverse sine a half? What's the only angle it gives you? 30. Then you have to come up with the other one, which is what? 150, but 2x equals that. So when 2x equals 30, what does x actually equal? 15. That's it. And then 2x. Does that come good?
Yeah, that's good.
2x also equals 150. What's wrong? He has a right to blow bubbles during my lessons? He does, you're right. Kind of loud, but that's okay. So same first step. The next thing, though, is we got a problem. What were the directions that I had you highlight? I need all answers between what? 0 to 6. You know what 150 divided by 2 is? What is that real quick? Isn't that really small? Might there be some other angles that work when I plug it in and double them and maybe between 0 and 360? There are. There actually are 2 more. So it's not a coincidence that there's 2 more answers. That 2 doubles the amount of answers. So that's our second thing that's changed. So now I'm going to reveal the next part. Here's what you do, and I want you to be robotic and just follow this because it works. So change number 1, 2x equals, and I must solve for 2x equals. I must divide these answers by 2. But the second thing, because of all answers between 0 and 360, I double. So how do I double? What's 390 compared to 30? How much bigger is this? What did I add? What did I add, everybody? 360. Add 360. Because you know why? 390 is coterminal with 30. They land in the same spot. This is just one more rotation. But watch what happens when you divide by 2. 195 is, anyone? Smaller than what number, which is what I'm supposed to answer for? Smaller from 0 to what? 360. So this is a valid answer there. And then I add 360 to 150 and I get 510. I gotta hide that. I just noticed that was there. Boink. And then 510 divided by 2 is 255. And then I'm going to go back to the directions for all of these examples. I needed all answers that work from 0 to 360 for this question. 255 works. And therefore, it's got to be part of those parameters in the question. Parameters is the correct word. How am I supposed to answer these questions from what to what? What do you think a 3x does? Triples the amount of answers, and that's what the next extrapolation is. You got some gum too. It's like, all right, now I do want to show you this. Zoom back into here. Why does 255 work? You should always think this when you're solving. High five. That was weird. 255 times 2 is 510. You know what 510 is? It's the same as what, everyone? Say it. 150. What's the sign of 150? A half. It works. It's true. That's what an equation solver is. So 255 works. When I go to plug in, and I got to double it first, which makes it 510, which is the same as 150. Sine of 150 is a half, so sine of 510 is a half. All right? So that's why this all happens. And then I don't know if I cut this off. Notice these angles are all between 0 and 360. That is why they all have to be listed. So often what people do on the test, which is Monday, remember, because I'm missing Friday, is forget to add 360. And then they lose half the answers. And some people just leave it blank. But that just happens every test. So I'm sorry. It's just the truth as we, deal with what we deal with this year. All right, don't do it, Miss Rose. Everyone ready? What do we say threes do? Triple. So we're getting, and again, I did this on purpose to extrapolate, like, what is the change? And then again, I want you to think about this when we do that. Get tricky with the video when they inverse sine both sides. When you inverse sine a half, you're getting that 30 again, but you freed 3x. So now you have to, divide by 3 after. But then there's a whole bunch of other stuff. It's not just 30, it's 150. You know the drill, chapter 2 and chapter 3. And then I got to triple it. So now I'm going to reveal the next parts. And then I'll create my own notes or made up notes. And obviously we're not going to go crazy on the test and say sine of 8x. Oh my gosh. That's 8 times. That'd be 16 answers on this question. We're not going to be that mean, but that is exactly what would happen, though. So we add 360 twice. So the two things that are changed, you freed 3x. So you got to divide by 3, 10 and 50. But then add 360, add 360. You have to do it twice. There's the tripling. So 360 plus 30, 360 again. All right, and then you go from there and divide by 3. Now notice the very biggest angle that you have here, 870 divided by 3 is 290, which is smaller than, say it everybody, 3, 2, 1, go. 360, that's why it's got to be listed according to the directions that we started with. And then as you're formally writing this down, please don't do the triangles. We're done and moved on from the triangles, but what happens when I plug in 290? The very first thing I have to do when I plug in 290 is multiply it by 3. That turns it into 870, which is just the same position as 150. It's the same triangle. That's why I drew the triangles, though. 870 is 1, 2 rotations, then hits this. And then what's the sine of 150 or the sine of 870? They're both a half. So it solves the equation. But the original answer is 290, which is between 0 and 360. I'm just going through why this actually works. I have a question, because I'm the teacher. What's the same thing as 360 in radians? 3, 2, 1, go. So we're going to go to radians right away after this. I actually feel like you guys are better with radians than you are with degrees. Maybe I'm wrong. I don't know. I think it's true for some of us. Sometimes I get you guys during the notes when I call your name out, like yesterday, and I actually felt there was more confidence in the radians. We got our over 4s, over 6s, over 3s done. We know the 180, that's 3 pi over 3, 4 pi over 4, 6 pi over 6. 360 is 8 pi over 4, not in any order. 6 pi over 3, 12 pi over 6. Anyone know what I'm talking about? So then the quadrant for 30-degree angle measure is 11 pi over 6. You're short of 12 pi over 6. So all that stuff. Okay, now, notice adding the 360s twice to triple. What happens on my next example when it's sine half x? What could that potentially do to the amount of valid answers? Half. Do I have to add any 360s? No, it's like less. You're going less. Or a third could be potentially a third of the amount of answers. And so on and so on and so forth. So that's what I have next. So this one, you'd be a silly fool to add 360 to try to create more answers. It could be half or not. You got to be careful. And again, we're really stuck in the directions of 0 to 360 to keep these all the same. So yet again, you freed x over 2. And then what do you have to do next to solve for x over 2? What do you have to do to both sides? 3, 2, 1, go. Multiply. That makes angles bigger, may throw them over 360, and then might not even need to be a valid answer under the directions. So you got to be careful on that. On the test, I think we do have a multiple choice where you do have to do some maybe all answers things. This one never. When we do these 3x, 2x, and x over 2 ones, it'll just be between 0 to 360 or 0 to 2 pi. But if you list an answer greater than 360, we got to mark it wrong because you didn't follow the directions. So the thing about math, we are sticklers about that. Again, I told you we don't need to be drawing triangles. And in this one, you do not need to be doing adding 360 because the x over 2, the half x, potentially could give us half of the answers that we had originally. But in this case, it didn't because 300 barely makes it under. So understanding this one, x over 2 equals the same thing, 30 and 150. But then when I multiply both sides by 2, okay, I still kept 2 answers. So I didn't lose the amount of my original question. But I don't have to add 360. I mean, if I added 360, then that would be 390 times 2. That's huge. And that's way bigger than 360. Understand the point. So only when it's 2x, 3x, 4x. I have asked 4x before. Oof, that's so mean. 4x would be like standard 8 answers. You got to write them all. Well, you see what happens with radians. I know what somebody would be like, Mike, get to write all that. That's a lot of writing, And I kind of kept the assignment to only like 6 measly questions. And then there's nothing new tomorrow. The test really should be Friday, but I don't know. I'll probably be a jerk again and do a quizzes, and then let's see who didn't do it, and then let's go ahead and compass them on Monday because you know how it happens, right, everyone? Right, Grant? Did you get compassed? I don't think you did. Did you?
Yesterday?
Yeah.
I don't think so.
Did you wear your no-show? I don't know.
Well, no, I ended up going to 10.
No. All right. Yes, I just picked my teeth during the video. All right. Anyway, let's move on. Are you guys ready? Okay. Now I'm going to make up some questions. You ready? Ready? Okay, so it didn't necessarily have to be half the amount of answers. But just imagine if this was cosine. Let's do it. If this was cosine x over 2. By the way, cosine of what kind of angle measure equals a half? 3, 2, 1, go. 60. It had to be 60. Where else is cosine positive? What quadrant? 4. So we got to imagine, use an imagination. This would be 60 and 300. What's double 60? 120. What's double 300? Would you list 600 as an answer? Not under the parameter, so there's only one answer. Got it? It'd be really tough if you're. These would be stupid if I made sine if that was negative a half, because then that would be 210, right? And 330, correct? What's double 210? Oh, 420. What's the date? Son of a nutcracker. Let's move on. Happens to be the date today, and then these clowns. Anyway, don't you dare. Don't you dare. Okay. All right. Okay. So let's go the other way. Let's go, and then let's do this. Directions. With me, caveman or cave person directions. All right. 0 to 2 pi. What does that mean now, everybody? Okay, so I'm just all the same directions, but now I'm going in radians. But I think you're going to be okay. And again, I've tried to train you. And I want to tell you what you did wrong in that one test where it was no calculator and you didn't cross cancel. Is it raining or no?
It was.
I feel like I see drops, but no. No, okay, good. It's always so gloomy out though. Anyone just feel that? Jeez, what a spring. I feel like we've had really bad springs lately. Anyone? Then one spring to summer, it was 50, 50, 50, 90. And we just completely missed spring completely. Oh, cosine of, let's go crazy, 3 theta equals, let's just do root 2 over 2, and instantaneously you should be able to tell me what the reference angle is. 3, 2, 1, go. It's a 45. So over here, we have 45s, and then what quadrant is cosine positive? 1 and 3, 2, 1, go. 4. Again, you're severely and totally behind if you don't know that. Put your ASTC thing down. We're trying to pound that in your head because not so much in 7, you get a break, and then we're going to end with chapter 8, and these 45s, 30s, and 60s, and no calculators, and knowing those ratios are going to come back again. Okay, by the way, what's equal to 360 degrees in radians? 2 pi. I'm going to do one more equals, but hold on. Let's get these 45s. Oh, and by the way, when you inverse cosine, you freed 3 theta. I should probably be using x if there's a math stickler watching. I don't know if we're doing radians. I think it's supposed to be x's, but who cares? What's the 45 and over what? 3, 2, 1, go. 4. So it's pi over 4. What's the quadrant 4, 1? It should be that fast. Don't be looking at them. I mean, congratulations. But everyone should be getting that right away because 8 pi over 4 is a full rotation. So I just answered that question. What's 2 pi equal to? Blank pi over 4. Just tell me. It's 8 pi over 4. So how many what happens to the amount of answers? And in degrees, I had to add 360, but in radians, I got to add 2 pi. And actually, I don't write it like this. I actually put this off to the side, and I take all of these and say, okay, 3 theta equals 1 pi over 4 plus 8 pi over 4. What is that? Again, this makes me want to throw a podium, not knowing this as a senior. 9 pi. It says 8 plus 1 pi. 9 pi. And it's not 9 pi over 8, which some of you tried to tell me on the chapter 6 test when they were dealing with fractions. Still, this is happening. Right? And then what's 7 pi plus 8 pi? 15. And how many times do I have to do this? How many more times do I have to do this? Just 1. From 2 to 6 answers. That's tripling. And then I look at this 8 pi over 4 and add it again, and I get 17 pi over 4. Right? And this does get a little annoying, but that's okay. 15, but that's 23 pi over 4. I should have done a negative ratio. That's okay. And then we're not going to divide by 3. This is what you do wrong all the time. With fractions, you're going to do what to both sides? 3, 2, 1, go. Multiply by 1/3. So I'm just going to eliminate all those and say I did multiply by 1/3 because you want to be careful. This is what you didn't do you didn't do on the last test, and some of you still refuse to do this. Now, I don't know if you have to necessarily write it, but I have a stupid question first. Does 3 go into 1? Yes or no? Okay, now this is what's killing me as well. What's 1 pi over 4 plus 1, or times 1/3? Sorry. Pi over 12. You just multiply across, and this is what we're not getting still. And that's not my fault. I can't do anything, but I you know what I have all year long? I've been a fraction jerk trying to pound these fractions into your head. Because I knew at this point, look at where we're at. We're almost in May, and here we are still doing and dealing with fractions. All right, and that's why I've been that way since the beginning. Does 3 go into 7? Does 3 go into 7? No, so what's this next answer? Simply 7 pi over what? Okay, I'm going to mark you wrong in this next one if you don't do this. Does 3 go into 9? How many times does 3 go into 9? So this is 3 pi over 4. This one does reduce, and you will have to reduce. It's smarter to cross cancel instead of multiplying and then have to reduce, rewriting it. Does 3 go into 15? Of course. How many times? 5 pi over 4. So weirdly, 2 of these reduce. And then I think you can see 17 is prime. So that's 17 pi 12ths over 12. And then 24 pi, and then, or no, 23 pi, sorry. That's not the pen, that's my brain. 23 pi 12ths, because I had this in my mind. What is 23 pi over 12 smaller than? What is 23 pi over 12 smaller than? 24 pi over 12 is a much more proving that you understand the concept answer. So that's why that has to be in the solution set. Nice. Let's keep going with radians. What did I do with the other hour? I did this. Actually, I screwed up in second hour or fourth hour. I wrote a ratio that doesn't end up being an exact, but this one does. Equals 3. First of all, what do I have to do to both sides? Oh, and I'm sorry. I'm a maroon. I need to put this as 2x. Otherwise, this is not the notes for this section. I do want you to understand this, too. I'll over-explain this why it's on the video. Cotan squared of 2x really just means cotan of whatever 2x is, and then squared. So how do I get rid of squared? I do what to both sides? Square root. Now, I want you to understand that 2x doesn't get affected. So it is still cotan of 2x freed now. Oh, by the way, what did I forget on the right side? 3, 2, 1, go. Plus or minus. Lindsay got that out fast. Nice. And then I don't think we should have to be doing the overs, but if it does help you, over 1. And then what's the reference angle? We should know immediately. So it's x over y. So what is it? 30. See, it's connecting now. And then what quadrants am I dealing with? Very simple. 3, 2, 1, go. All. When you get that plus minus thing, it's all. How many answers am I going to have at the end? Total. 8 is a very good answer. Good. Because 2x equals, well, let's get that figured out. It's a 30. And if I'm going too fast, over 1, yx, how we're really doing. Wrong. That's a bad on my part. Ooh, showed my whole arm there right in front of x over y. Y is the reference angle side. 30s are opposite 1. So it's a 30 in all. Should say all 30s. What are the 30s over what's? 3, 2, 1, go. 6. So first one's pi over 6. What's the next one? 3, 2, 1, go. That's not good enough. 3, 2, 1, go. Geez, you on it over there, not answering questions. 5 pi over 6. What's the next one? 7. She answered now because I was about to call her out personally. That's what I do. And then what's the last one? 12 pi over 6. Jump backwards. 11 pi over 6. All right. It's annoying. And then what is 2 pi that I have to add to this? What is 2 pi that I have to add to this? 12 pi over 6. Sometimes I write it like this. Now I have to take 12 pi over 6 and add it to all of these. And then write 2x equals for that little thing. And then I'll write the final answers there. Well, that's 13 pi over 6. Speed this up. This is 17 pi over 6. So it does take some writing. 19 pi. That's why I get really angry over the years what's happened to math. You should have them write sentences about what they did, what they learned. And there's more writing in math than any other class. Who agrees with that? Raise your hand. Well, unless you don't do your homework. Some guys, I don't do any writing. You don't do any homework. All right, anyway. Huh? There's no writing at all. All right, what do I have to do to both sides? Not divide by 2, but does 2 go in 1, 5, 7, 11, 13, 17, 19, or 23? Yes or no? No. So annoyingly, here's what x is. Pi over 12. 5, they're all over 12s. So you annoyingly have to write them all. So the only annoyance is that you have to write your answers. So again, 2 doesn't go into any of those odd numbers up at the top. So 8 answers. So do you think we're going to be jerks and say sine of 8x? Do you think we will? He says yes. Doesn't matter. You don't do your homework, so you don't have to write it, right? That's true. It's true. We just speak truths in here. We're done playing around. That's me and my many personalities. Anyone watching Moon Knight, by the way? Speaking of that, nice. Isn't that a good segue? Did you see last night's episode? You'd have to stay up till 2 in the morning. Right. Anyway, I'll probably watch it tonight. Nobody. Is today only Wednesday?
Yeah.
I just had a flash that it was Thursday. This is like my Thursday because I'm missing Friday. Nice. I don't know. Do I really? Yeah, I got to do one more. How is this one different? Don't answer that yet. Sine of 2 theta equals. You ready? Are you ready for this? Boom, 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 boom. Cosine of theta. It essentially is not a ratio of sides. I forgot to show this last hour after I'm done with this one, why you would not want to do what I do here to our second example of the day. But I don't have a way of solving this. As a matter of fact, these are not even the same angle measures. So I can't even compare these and try any kind of thing here. And I can't do the double the answers. I can't even get answers out of sine of 2 theta equals cosine of theta. So there is one question I assigned like this. Actually, it's sine of 2 theta equals sine. All right, that's number 17. So I made up this one. So what you got to do is put this in terms of theta. And there's a way to do that from chapter 5. Does everyone remember what sine of 2 theta equals? It's an identity. Do you remember it? What'd you say? No, that's not it. I thought you were giving me something. Don't look it up. I want to see if anyone can just from doing their homework over and over and over again remember it. He won't do it. He really hammered this non-homework doing guy over here. Nobody? There's a 2 in it. Anyone remember it now? Sine 2 theta is 2. Come on. Sine theta. Anything else? There you go. It was the homework guy. How ironic. Or the non-homework guy. Did I call you the homework guy? You would not want to do this on this one. And that's where you got to understand the difference. And these differences. Look at the notes we used to do. Holy cow. All right. You would not want to do this on this one because then this is what would happen. Sine 2 theta. If you made that 2 sine theta cosine theta equals a ratio, what are you going to do now? You just made this 2 variables. You made this unsolvable. Sure, I can multiply both sides by 1/2, but now you have sine times cosine equals 1/4. This puts you in a bad position. You're better off just freeing the 2x by inverse signing and then going, so when it's sine of a number times x equals a ratio, you stick with this method. All right, got to be able to toggle between different methods here, depending on what's given. I mean, did I? Oh no. Look at all those notes. Oh, look at those. Look at this. Oh, look at those things. I see calculator questions we used to do. I just said, did I say that to you guys? We've been short on calculator questions this year. Oh my gosh. I just got down there. Did you just see what happened? It just flipped me back to the top of the page because this computer program is driving me nuts. It's the worst computer program I've ever taught notes on. It's really true. You know what's better than this? The chalkboard. I really miss the chalkboard. This thing makes me miss. Anyway. Now what do I do? Do I divide by cosine? No. What do you do with the cosine, everybody? 3, 2, 1, go. Subtract. We're staying blue. And then what do? Starts with an F. We did this yesterday. You were forced to do this. Factor. So again, as your memory, you got to remember from one day to the next. And actually from, well, I can't argue that this is math 2, but the idea is from math 2. The idea of GCFing. Math 2 student would faint seeing this right now. And then what? ZPP. Lindsay got this question. What's ZPP, Lindsay? Zero product property. Everyone should know it. This one you should know. That's the math 2 concept. And then sine. This did not go well yesterday. I don't understand what the problem was. If I set 2 sine theta minus 1 equal to 0, what does sine theta equal? 3, 2, 1, go. Only a couple people said a half. You add 1, divide by 2. We should, as at high-level CAT students, seeing the zero product property for 3 years, maybe 4 years straight, understand when I set that equal to 0, this is what happens. Hey, what's the first set of angle measures? Where do you get 0 for x and 1 for r? What angle measures? 3, 2, 1, go. I think I kept this whole section in radians, so let's keep it in radians. So yes, 90 and 270 are what? And then notice I'm not, wait, how come you didn't put, this is what theta equals. So I'm done. I don't have any number in front of this. It's I'm in tutoring, try to say it was 2. Do I divide by 2 now or what? No, there's no, we changed sine 2 theta to 2 sine theta cosine theta. We got rid of the 2 basically through an identity switch. And it is really a switch. That's what chapter 3 was all about, or 5. And then 3 pi over 2. And then I'm almost done. I'll shut up after this. What's the next one? Sure, they're God, we better know what the angle measures in degrees. The 30 and what? Or they're the 30. So the over what? Over what? And then what's the other one in quadrant 2? All right, we're done. We've mentioned that one quite a bit. So I told you that's how important chapter 2 and 3 were. Really hope I'm picking up more. That this is getting better. But, it's up to you at this point, getting these